Hi! This week we have a pretty big video. We're going to talk about client prediction. If you have tried the last video with the network transform component, you're going to see that it caused some input lag. It depends on where you are, how far away from the server you are, but you can feel some input lag while you're like turning around and moving as a client. On my side, it was pretty bad when I did it this summer. So I tried to find other way to do it, and client prediction is one of those things you can do to improve that. So basically, client prediction means instead of like sending your input to the server and he moves you, and then you see the impact of your movement, you actually move, then send your input to the server, and the server is going to answer you back and tell you if what you did, the move you did, is the right one. So it's going to give you the position that you're supposed to be. There's a lot of setup for that to work. We are going to have to implement fixed tick rate. We're going to also have to implement then the client prediction. There's going to be other topics coming in the future. This is not a full implementation. This is just client prediction. Usually it comes with other things. Like reconciliation and interpolation, but we're going to focus on client prediction for this video. I'm also going to give you a couple of different resources if you want to kind of just see other ways of people explaining what client prediction is. There's a great video from the Overwatch team where they explain their netcode, and basically they go through all of this with great graphics, so it's super easy to understand. And I'm going to also give you another video which is kind of someone going through an implementation, and that's the implementation I based my code on for this video. So it's gonna be super great. After that, the both player controller on the client and the host are gonna feel snappy. Let's get started. Okay, so we're gonna start where we left off. So this is the basic player controller implementation, and now instead of doing like the full movement here directly on the player controller, we're going to create another component that's going to be responsible for the movement. So this is a component that is easy to reuse from project to project. So we're going to put it in the game framework. We're going to create a directory. Network. And then inside of it, we're going to create another directory called movement. There you go. And then here we're going to create our component, which is network movement component. Okay, and it's going to be a class. There we go. So this is going to be where we actually put things that we need for that client prediction. So we're going to start by just putting the variables of things like we need. So I'm going to go with the serialize. We're going to need the player controller. So character controller, CC. Then we're going to need another serialized field, speed. Oops, sorry about that. Float speed. We're going to need actually another one for the turn speed, which is a rotation speed. We're going to need a transform for the camera socket to like it's essentially like same of the same thing. It's just that we're going to migrate like the rotation and everything, and the rotation is based on the left right movement is based on the camera transform. So let's go with transform cam socket, and then we're going to need another variable, which is the Gameobject, the virtual cam vcam. Okay, so that's good. So what we're gonna store, in fact, whenever we get this, the vcam transform. So vcam transform, and then here we're gonna need some variable for actually calculating the tick rate. So we're gonna go here, private int tick. So this is the current tick. So right now we're gonna start always at 0. They're all gonna start at 0. Private float the tick rate, which is basically the millisecond of the update. So let's say you want right now we're gonna go for 60 FPS. So we're gonna go for 60 F. Private float tick delta time, so how much time since the last tick. Tick delta time. It's going to start at 0. And then what we want to do is we're going to store the input that we sent to the server so that we can compare it whenever we receive an answer from the server. So basically, like, if I had to explain it, it's basically like we move on your local for client prediction. We move on the local, we send that input to the server, and we store locally the input we send with the tick to which we sent it, so that whenever the server answers us back, he's going to say, okay, you know that tick, you know that input you send me at this tick, it's fine, it's validated, you've moved, everything's fine. So then you can, on your side, forget about it. But if you didn't, if you say, oh, you know, it was miscalculated, in fact, the position you should have been at this tick is this, then we're going to be able to say, okay, let me go back to the input I've sent you, find the one at that tick, change it to the position that the server actually corrected, and then reapply all the other inputs. So it's a little bit complicated. I'm really hoping you guys will take some time to read to go through the videos I'm gonna be listing because it's a lot of things to kind of wrap your head around. Okay, so now we need, as I said, we have a buffer size. So that buffer size is how much input I'm keeping in storage, waiting for the player to answer me. So we have 1024 input that we're going to store before we're like, okay, I should like this is a maximum number of input I'm keeping in store. Usually you're not going to have 1024 because the server answers you and then you clear them, but this is kind of to give you some space if the server is not answering you, you know. So yeah, so we're going to create another class because now we have a buffer size, but we need to actually have a class that represents that input that we sent to the server. So in here we're going to create a new class. Input state. Okay, so in here, sorry, what we actually need is we need to know the tick of like when we send that information. So let's go tick. We're gonna store the input. So this is actually the information we're sending to the server. So the movement input. It's the same thing that we were sending before. So that and then the look input. If you remember correctly here, when we were doing a move server RPC, we were sending the movement input and the look input. We're still sending the same thing. We're just wrapping it into an input state. And we're putting a tick so that we can sync the server and the client to say like, because maybe the client send two movement input before you receive an answer for the first one. So that's going to give us a way to identify like when in time I've sent that input. So yeah, so here what we can do in the movement component, we're going to go and create an array of this. So input state array, and then input state, and we're going to create a new array of the buffer size. So this is the max input, the max number of input I can keep in memory for this kind of this movement component. So yeah. Now what we're gonna have to do is we need to whenever we move, store the state that we arrived to. So let's say I was at a certain point, I send my input state, store it into that, and then I store the result of my movement. So whenever I moved, where did I arrive? So I'm gonna need to store that so that whenever the player also move us and give us back like where he arrived when he moved us at that point, we can make sure that we are at the exact same spot that the server calculated. But we didn't have to wait for him to answer us, and we've already moved. So for that, we're going to need a new class. So for that, for storing the movement, what we're going to do is we're going to do a new class, which is called a TransformState. So the TransformState is also going to be used for us to send things between the client and the server. So it needs to be what we call a network variable. So a network variable is basically a variable that can be synced between the server and the client, and you can listen to changes on that variable so that if the server modify the value of that variable, you get notified and then you can act on it. So we're going to create our own type of variable for that. So what we're going to do is we're going to go in movement, add a class, and transform state. There you go. So that's going to be what we use. So for that, it's going to inherit from network serializable. So that's going to force us to implement a couple methods, which is like to tell Unity how to actually change this into a network message. So here, it depends highly on what are the variables. So let's check the variable first. So first we're going to say we need a tick also. We need also vector3 for what's the position that we arrived to. So the position. And we need also quaternion, which is the rotation. Okay, so that's basically it. So in here, this is not a lot of, this is not super intuitive, but this network serializer is going to be called whenever you want to send something and whenever you receive a value. So we need to kind of check in which mode it is right now. So is reader means I'm receiving it, so I'm reading the value from the network. So then what we want to do is we want to take that var reader equal serializer dot get fast buffer reader, and then what we do is we read the value. So we want to read first value. Oh, sorry about that. Value safe, and then we're going to put out the tick, and then here the order in which you read it needs to be the same that you're going to write it to. So that's just how network messages works. So now we're going to send the tick first. So we're going to read the tick first. Read value safe again. We're going to put it into the position. And we do the same for the rotation. Oh, sorry. And the rotation. Okay. Yeah. So that all looks fine. And we're going to send also a bool, in fact, has started moving, which is going to be needed. I'm not going to show you why. We're going to see it later, but we're going to see that. So as started moving. Okay, so basically, if you're not a reader, then you're a writer. So we're going to say here writer equals serializer.get fast buffer, but the writer part. And then we go writer dot write value safe, and we pass it the tick, and then we pass it the position, rotation, oops, and has started moving. And here we go. Now we have a transform state that can be used as a network variable for us to know whenever the server has actually updated our position. And we can store also our own position that we, what was the calculation of our movement that we calculated before sending it to the server. So now back in here, we're gonna store this. So, oops, sorry, private transform state, which is going to be an array of transform states here, which is going to be a new transform state of the buffer size, because it's the same. Every time we send an input, we want to store the transform state that we arrive to. So it needs to be the same size, because those are going to be like the same number, same amount. Okay, so now what we want is we want the server to be able to send us this type of information. So network variable, and we want it to be a transform state. And this is the server transform state. So it's the latest value. It's the latest value that the server has kind of went through and sent us an answer for. So basically, this is the latest transform on the server. And we can store that, in fact. So let's go here, transform state, and say previous transform state. So that's perfect. Now we're kind of ready to start. So first thing we're gonna do, we're gonna listen to that server change, that server variable. So we're gonna do on enable. It doesn't want to generate it. On enable. Oh yeah, it doesn't want to because I forgot to put this as a network behavior. There we go. Now we're gonna be able to generate it. Cool. There you go. So now on enable, we want to listen to that variable change. So it's mostly how you would do on for any event. So this, then we go plus equals, and then you can create a method on value change, which to me, I'm gonna call it on server state change. There we go. So we get the previous transform state and then the new value. So what we're going to do in here is simply set, for now, our previous state to be the previous value. Okay, so for now, we're not, so here is, it's actually where you would do like the reconciliation, because it's the server telling you like, okay, here's my new value. So here, my new value here as a tick, and it has the position and the rotation that the server has for that, as calculated for that tick. So so right now we're not going to do, as I said, the reconciliation, but we're going to do in a future video. So for now, let's keep it there and just make sure that we're kind of already set with that. And now what I want us to do is enable the player controller to call method for actually moving. So what we're going to do is we're going to start with the one that has a client prediction. So process local player movement. Okay, so that takes exactly the same thing as before the other movement method was taking. So a vector2, which is movement input, and then another vector2, which is a look input. And there we go. Okay, so now in here, what we need to do is, first of all, we now need to think of, we're not using anymore time to delta time, we're using our tick delta time. So what we first need to do is do tick delta time plus equals time dot delta time. Because the tick also has like kind of another benefit. It makes us so that we don't, let's say you have a computer that processes input super quickly and mine is a little bit slower, then you would send a lot more input than me in the same time that my computer processes the game and send input. So we don't want that. So it kind of caps you, like I treat your input every X amount of time if you tick rate. So we're going to check, and only if we're in that tick rate, tick delta time is greater than the tick rate, only then we actually process your input. Okay, so now we're gonna look into like, where are we in the buffer right now? So we're gonna do int buffer index equals the tick modulo the buffer size. Okay, so it's going to give us like that point in the buffer size, or where we at, and we're going to say if we're not the server, so we're not is server, then what we need to do is we're client, so we need to send our input to the server. So we're going to do move player server RPC. And then it's going to be a function we're going to create. It's going to be pretty similar to what we had before, but now it's going to take into account the tick. So there we go. We're going to send the tick, the movement input, and then the look input. Okay, so now we're going to go and do that function. So am I in the right place right now? No, it's after this one. Oops, sorry. Okay, so let's go and do a private void move input. So it take a hint stick, vector2 movement input, and vector2 look input. And we don't forget, we need to put here server RPC. No, in fact, it's RPC like this. So let's change it here. Okay, so this is the method that actually process the player movement. So we're going to call in here a move player method, which we're going to pass move player method, where we're going to send a movement input, and rotate player, which is going to take the look input. Okay, so let's create those. We'll create it here because this is a method that's also going to be used by the client. So here, vector2, it takes the movement input. There you go. So the move player, you're going to see it's pretty much the same we already did. So we can redo it because it's quick. So the movement is equal to movement input.x times, and then we need the camera transform. So after the unenable here, we're gonna go and do on network spawn, and we're gonna store the cam transform. So vcam transform equals vcam dot transform. Okay, there you go. So now we have that vcam transform. We can go back down here to actually move our player. So then we're gonna multiply it by the vcam transform dot right, and we're gonna add to that the movement input dot y times the vcam transform dot forward. There we go. So that gives us like the movement, but based on where the camera is looking. We're gonna cancel any Y movement. And while we're here, we're gonna implement gravity. So let's say if the character controller is grounded, we're gonna do like, we could do a custom ground check. Like right now, I just wanna do this. So movement.y equals minus 9.61f, which is gravity. I think there's actually, yeah, there's actually something here. I think I just have to say that y, is it that, right? I think gravity is vector 3. Yeah, so I think it should be, but you know what? I just want, just to be sure, I kind of want to do minus 9.61f, because this is usually gravity is something you're going to want to maybe tweak in your game if you're not using physics, and you have custom physics, and we're going to ask the character controller to move us. So it's that movement, that speed, and here normally we would time the delta time, but now it's our tick rate. There you go. All right. So that means we're all moving at the same time from the same tick rate. Like whenever you move, you're gonna have the same time, the delta time. So it's gonna make it so smooth on everywhere. Okay, so now what we're gonna do is we're gonna do the rotate player, void rotate player. Here it's gonna take vector 2, look input. There you go. And now in the last video, we weren't really implementing the rotation of the camera on the server because like the server doesn't really have doesn't really see the camera on other hosts. But now I'm gonna do it, and I'm gonna explain it why. Let's say in your feature, like you're playing like something like Call of Duty, you know, where you have like death cam and stuff like that. You might want to actually rotate the camera to kind of keep the feed of like what the player was seeing, and then replay that. For now, we're not going to implement any of this, but it's useful to have the camera rotating also. So we're going to do vcam transform.rotate around. Rotate around. It's going to rotate around its own position. Vcam GameTransform.right, because this is the axis we want to rotate around, and it's going to do the look input dot y times the turn speed times again the tick rate. There you go. So that's for rotating the camera. And now we're going to rotate our player with the other input from the look input. So rotate around, still transform dot position, not the vcam, but now our transform, because that's a player rotating. Transform dot up, because we're rotating left to right. The look input dot x time turn speed time tick rate. And there we go. Now our server and our player will be able to move the player and rotate the player. Okay, so now that we have those methods and that the server actually moved the player and rotate the player, what we need to do is actually store what was the position that we arrived to from that for that input and that look at that tick. So that's why we did the transform state. So we're going to do a new transform state. Transform state. Well, let's call it state equals new transform state. And then we can already set the variables. So the tick is actually the tick that was passed. Here, there you go. Then the position is going to be the transform dot position. The rotation is going to be the transform dot rotation. And the has started moving is going to be equals to true, because we just received a movement. So that means the player has started the movement. Okay, so now what we're going to do is we're going to store that state as our previous state and update the transform.state value to that state. In fact, no, that's not true. We're going to do this to whatever it was, and then we're updating the value to that new state. So this is a weirdly named thing. It should not have a capital P. Let me just fix that real quick. So previous state. So here, let's change it, and then let's go down and change this. So why are we storing the previous transform state? So there's sometimes things like your client is going to send the input to the server, but the packet containing that information of the input is going to get lost. So the server is actually never receiving it. So this is a problem that can occur because that's how the internet works. And doing a multiplayer game has kind of that complexity where sometimes you actually move, you tell the server you move, but the server never received it. We're not going to take into account this because we're dealing with a game right now that doesn't send a lot of traffic, so there's not a lot of messages that are lost. But if you want to know if you lost a package, here you could test it. You could say, okay, you could actually test this like before even moving, saying like if tick is not equal to previous transform state that tick plus 1, then I lost a message. Like, I'm not going to put it, but if like the tick that you're receiving right now is not directly the latest tick you have plus 1, then you lost some message, you know? Like I've lost some messages. So that means at that point you should notify the client and say, hey, by the way, I'm missing a message, you know? So you could have like a network variable with ints, an array of ints or something like that, that is like the one that you actually miss. And then the player on that change would send it back to you because we stored it, remember? We stored it into the input state and the transform state. Well, we haven't done it, but we're going to do it. So then the player could say, okay, let me look up into my own record of what I've sent you and send it back to you. Okay, so that way like the player can adjust and the server can adjust too. You're going to see this in the video of Overwatch. You can have like time contraction so that the player send back the input quickly and the server kind of catches up, and then the player kind of change. So we would change like the tick rate for a certain amount of time so that we catch up and send the input we missed, and then we could catch up. But for now, we're keeping things simple, and I'm feeling like for most of the game that we're actually using, since we're not doing like Overwatch or an FPS or stuff like that, you shouldn't feel it at all. But this is something we can correct in the future. So that's it for the actual move on the server side. Now let's go into where we're using it on the process local. So we've sent that to the server. Now, what we actually need to do on our side is the client prediction. So what we're going to do is, hey, I'm moving, okay? So move player, we can put move input, and then rotate player, and we're passing the look input. So that means usually we would do that and then wait for the server to answer us, and then we would, because the way it was before was we're not syncing ourselves with the server. We send to the server changes, and the network transform component kind of moves us after that. So now we don't want to do that. We want to send the server our information of how we moved, and then we want to move immediately. Okay, so that's kind of the difference. Yeah. So this is if you're a client. If you're not a client, then you're the server. Then you kind of don't need to do that. You can just move the player, movement input, and rotate the player with the look input. Okay, so here you have we have processed this. Now we're gonna store the transform state that we arrived to in a state, new transform state. Do this. Now we want to save like we did on the server. So the tick, we're going to store the position we arrived to be transformed to position. We're going to store the rotation, transform.rotation, and we're going to say that we started moving. Okay, so, oops, sorry. Here, we need to do this, and we're going to store the previous transfer state to server transform state dot value, and the server transform state dot value equals our state. So basically, we just need to do this. It's the same thing that we would do if this were to happen, but we don't need to actually like send an RPC and wait for it to come back and everything, because we are the server, so we don't need that. That's also why we don't really need to store the input, because the server input doesn't really matter. It's like there's no validation to be needed. Like he's the server, so he moves however he wants. Okay, so let's go here. So now what we want to do is we want to store for all the other ones the input state. Input state equals new input state. And here we're going to start with the tick, which is equal to the tick. And then what's happening? Oh, yeah, it's input state. Sorry about that. It's equal, new input state. It's equal to the tick, and then the movement input is equal to movement input, and then the look input is equal to look input. Here we go. So that's our input state, and then we're gonna store the transform state. So since we've already done it here, we can. In here, we're gonna do it in here. Well, you know what? Yeah, let's store it here. We can fix it later because there's got some kind of duplication here. But since it's working, I just don't want to mess it up. So new transform state. Here we're gonna say the tick is equal to the tick. So basically, we're doing kind of the same thing that the server does, so that we can keep a record ourselves too. So position equals transform.position that we arrive to, rotation, sorry, transform.rotation, and the has started moving is equal to true. Okay, so there we go. And now we're gonna store it on our local input state. So buffer index, sorry, is equal to the input state. Yeah, and the transform state at the buffer index is equal to the transform state. Now that this is done, we can do tick.delta time minus equal the tick rate, and we update the tick. Okay, so that's basically how you would process a client, a local player movement. Okay, so this is simply that. Now we're gonna have another method to process any player that is simulated on our game that is not actually the local player, because in that case it's an easier process because you're just gonna look at the state of the variable and move that player. So we can go ahead and do it. Let's do public void process simulated player movement. So this is all the other player in our game that are not us. So tick delta time plus equal time dot delta time. There's a lot of optimization that could be done in this thing, and we might optimize it later, but for now it's fine. So time delta time is greater than the tick rate. Then that means it's time to process the input. So we're gonna do if server transform.state.value has started moving. So if the actual value, like we have has started moving, then we just set the position to the server transform.state.value.position, and we set the transform.rotation to the server transform.state.value.rotation. And then we do basically the same thing, tick delta time minus equal tick rate, and then tick plus plus. So that's basically it. Okay, so this is a pretty standard. I don't even think we need to do this. I don't think we need to do this either. I'm gonna test it and maybe remove it in a later video, but for now this I know works. So right now we have implemented the client prediction, and we are ready to kind of use this into our own player controller. Now here we can actually get rid of those methods and move server RPC, because we're not really gonna use that anymore. We can get at the top here, there's things we won't really need anymore. We won't need the speed, the turn speed, that's for sure. I don't even think, yeah, we do need the cam transform, that we need. And min max rotation was in the rotate camera, so this we might want to move it, so I'm going to keep it around because we want sorry guys, it's late. We might want to actually reuse this code, so for now I'm just going to comment it out, and we're going to move it later maybe in the network movement component, so that we keep the same feature for the clamp. And here in the update, that's where it's going to change. So first we're going to go at top, and we're going to get a reference to our player movement. So serialize private network movement component. So player movement. Okay, let's go like this. And then in our update now, if we scroll down here, it's gonna change a little bit. So what we want to know now, if it's the client and the local player, we want to use our player movement component and do process local player, and we're gonna give it the movement input and the look input. Now if it's anyone else, it's a simulated player, so we're gonna do player movement dot process simulated movement, and that's kind of it. And then here he's just gonna use the value of the server to actually set the position. So for now, that's all we need to do for the player controller. Okay, so actually, we're gonna remove this part because it's causing issue right now, and we don't need it. It was just an example. So let's remove this thing, and then we're gonna move into Unity. We're gonna need to do a couple changes. So in the prefab of the player, right here on the playfab, you need to add the network component. We can remove the network transform component from Unity. We had our network movement component and just link everything. So we need to link the network to the player controller, and then we can set the variables here for the speed and the turn speed, the camera socket, and the VCam to the same thing that it was on the player controller. Another change that I did was just that on my scene, I don't know why, in the blue map, the player was falling through the ground, so I just like moved it down a little bit so that they fall on the floor. Okay, so now we're gonna host here, join here. Let's go RG. There you go. So now we join. Okay, we can ready up here. And we just start. And then here, I'm gonna move away so that the other player can join. And here it is. And now you're gonna see that the movement actually feels way better. You're feeling like both the players are kind of moving at the same speed. So that's exactly what we needed from that tutorial. So there you go. And there it is for our network player movement. This was a big video, and I know it's like the third video on the player movement, but player movement is such an important part of a multiplayer game that it kind of needs to be shown this way so that you can see what happens when you don't have any networking, what happens with Unity's networking solution with a server authoritative, and then what we have with a client prediction. I'm gonna release a short video soon so that you guys can kind of like keep the rhythm and not just be bored by player movement on a little switch. So we're gonna reuse the network variable in the context of you have a game component, which is a switch, and you want to open a door when the players are both on the switches. So yeah, so that's gonna be in the next video. So if you like this video, please like, subscribe, and hit the notification bell. Thank you for watching, and I'll see you in the next video.